sometime, I want to say in the early 80s, A&W, don't have many of those around here, but A&W branded themselves or branded a new product. They went with a 1/3 pound hamburger, and they had great slogans. They had great things that were out there. You see the great picture right here, and it flopped. It totally didn't work. In a follow-up study, as they were talking to individuals, most of the feedback from people was, well, why would I pay more money for 1/3 of a pound when I can get a 1/4 pound for less, or for more? And what it really revealed is that most of the people that were going to fast food joints, they thought that 1/3 was less than 1/4 of a pound. All right. So fractions can be challenging. They're not meant to be challenging. So let's try to simplify some of this, because what we actually know to be true is that, yeah, this is not true. 1/3 of a pound is actually more than 1/4 pound. So when we have fractions, we want to add fractions. One of the things we always have to remember, and we'll just go back and forth on these things, is that when we're adding fractions, we have to have them relative to the same grouping sizes. So anybody that's done any baking knows this as well. If I have a 1/4 and I add 1/4 of a cup, I'm going to have then 2/4 of a cup, which is 1/2 of a cup. All right. If I have a 1/4 of a teaspoon and I need to add 1/8 of a teaspoon, I can't add them directly the way they are, so I need to have common denominators. So that 1/4 I'm unreducing. Remember reducing? So I'm unreducing, so that becomes 2/8 plus 1/8. Now we have them on the same relative scale, so now I have 3/8. And then there will obviously be more challenging fractions that we'll do along the lines and along our time. Maybe it's 1/3 plus 2/7. And now I need to make them on the same scale. Well, 3 and 7 aren't easily converted into something, so I need to find a common denominator, ideally the lowest one. In this case, the smallest number that both 3 and 7 go into is 21, so I'm going to have two fractions that are out of 21. And how do I get from 3 to 21? Well, I multiplied it by 7. Now, technically, I'm multiplying it by 7 over 7, because 7 over 7 is 1. I'm not actually changing the value, I'm just changing how it looks. So then I end up with 7/21. And then that second fraction, I'm multiplying it by 3 over 3. Again, 3 over 3 is just 1, so I'm not changing the value of 2/7, just changing the way it looks. So then I'll have 3 times 2, which is 6 over 21. I'm already kind of getting into multiplying fractions, which is another thing we'll do a little bit later here. But anyways, now I have 13/21. 13 and 21 are both prime, therefore there's nothing I can do. Let's move on to subtracting fractions. Same idea. If I want to be subtracting fractions, I need to be doing them on the same scale. So if I have 3/4 and I'm subtracting 1/4, I'm going to end up with 2/4, which I can then reduce to be 1/2. When I'm doing on separate scales, 3/4 minus 1/8, I need to make sure that I have fractions that are in similar proportion to one another, or in similar format, if you will. I want them both to be in eighths, and the reason why I want both eighths is because 4 and 8 are divisible one to the other. So how do I go from 4 to 8? I'm going to be multiplying this first fraction by 2 over 2. Again, 2 over 2, this is 1, so if I go 3/4 times 1, I still get 3/4. I just change the way it looks, or you can think I'm unreducing, and I multiply, so this would then be 6/8 minus 1/8 will give me 5/8, not reducible. Move on to 2 that are totally, let's go 1/2 minus, let's go 7/6. No, let's go 7/9. We'll go like that. All right, now I'm looking for two numbers that they both the denominators, 2 and 9. Is there a number both of them can go into? And the answer is yeah, there's a lot of them. If you can't come up with one, you can always just multiply the 2 and we get 18. Is there a number smaller than that? In this case, there's not, because 2 times 9, so this will equal something over 18 minus something over 18. And how do I go from? So this would be times 9 over 9. This one over here would be times 2 over 2. So I'll have 9/18 minus 14/18. It'll be something over 18. 9 minus 14. So I have 9 taking away 14. I'm taking away more than I have, so I'm going to be in a deficit. So I have negative 5/18. Cannot be reduced. And we move on. Multiplying fractions. The advantage with multiplying fractions is that it is fairly straightforward. 1/2 times 1/2 is just straight off multiplication, 1/4. The way to think of this, though, is this is the mathematical model like we did in one of the other videos. 1/2 of 1/2 is 1/4. So 1/2 of 1/2. So you have 1/2 a pizza, take half of that, I got enough for 1/4 of a pizza. So when we're thinking of multiplying, that multiplying oftentimes gets translated into the word of. Okay, so 1/3 of 1/2 is 1/6. 2/3 of 1/2 is 2/6, which is 1/3. If we look back at this, you could say it the other way around. What's half of 2/3? Half of 2/3 is 1/3. So 2/3 of 1/2, it's the same thing. So multiplication is commutative. We'll get to those later, but that means they can be done in either order. Addition is commutative, subtraction is not. All right, so in this case, if you see this, you could do mental math and say, well, half of 2/3, well, 2/3, what's half of 2/3? 1/3, because they're both the same size. And then finally, dividing fractions. This is where sometimes people get a little woozy on things, but what we're really looking at is it's how many goes into the other one. So if I have 1/2 of something, let's see, if I have 1/2 of something, and I want to divide that in half. All right, what does that mean? Not dividing it in half, it's what's 1/2 divided by 1/2. A couple ways of thinking about this. This is the same thing as saying, well, if I have 1/2 divided by 1/2, just like if I have A divided by A, I have something divided by itself, this equals 1. How do I show this over here? Phrase you may have learned in the past or procedure is to say when you divide by a fraction, it's the same as multiplying by the reciprocal, which means you take the second number and flip it. So dividing by a fraction is multiplying by a reciprocal. So now I have 2/2, which is 1. A lot of processes you can think about when you're dividing fractions. No one is necessarily better than the other. Let's try some a little bit harder fractions. So if I have 5/7 divided by 2/3, we're asking how many 2/3 goes into 5/7. And 5/7 isn't something that most people can think of and say, oh, I can visualize what that is. If you wanted to visualize this, we would take this and say, all right, let's make them, you don't have to do this. What I'm doing here is like supplementary. But if I take them and do them as common denominators, 21, all right, and so this would be 15 21s, and this would be 14 21s. So how many 14 21s goes into 15 21s? Well, 1 plus a little bit. All right, so how do we do that? Mathematically, arithmetically, we're going to say 5/7 times 3/2. All right, because I'm taking it and I'm multiplying, so I'm going to get 15/14, which is 1 and 1/14. All right, how many of these goes into that one? All right, I'm going to have 1 go in there, and then how much is left of the 15? There's 1 left over of the 14 that I'm trying to go into it. So that's how it's coming up with that idea. Most people like to just work through the algorithm that we use for dividing fractions. Last thing, order of operations. When I'm doing fractions and reducing, I need to be careful that when I'm reducing, I can reduce when I'm multiplying. So as we looked at this up here in the past, when you've done this, adding and subtracting are inverse operations, multiplying and dividing are inverse operations, exponents and roots or radicals are inverse operations. So when I'm reducing, what I'm really doing is I'm dividing. And I can only divide things that are being multiplied. So if I have multiplying and dividing going on here, I can reduce the c over c as to 1, leaving me with a over b. In this case, I have adding going on, and a very common mistake is people will try to reduce this, the c and the c, but that is not correct mathematics. You can't do that. My answer will be a plus c over b plus c. It cannot reduce. Now here it gets confusing for some because they say, well, there's adding going on. Well, there's also multiplying going on. And we remember that parentheses essentially says this is all one thing. So if I wanted to rewrite that, I could say, well, let's let x equal c plus d. So if I do that, then this equation becomes a times x over b times x, because I'm just replacing it. C plus d is x, so I'm just substituting it in there, substituting in there. Now it looks a lot like that first one, and since they are exactly the same and they're multiplied, they reduce, leaving me with a over b. Notice I don't say cancel. They reduce because they're identical. When two things are divided and they're identical, c plus d divided by c plus d is 1. A over b times 1 is a over b, and that was my solution to there. That's enough on fractions today. Remember, fractions are your friends, not food.